Assalamualaikum warahmatullahi wabarakatuh and good morning.
Good morning, sir.
Salam, good morning.
Good morning, sir.
Morning, sir.
Morning, sir.
Morning, sir.
Before we proceed with new chapter discussion, okay, let us look at last week lab exercise. Okay, the topic, although the topic is loop logic structure, however, the content is, if you notice, there's also a decision over here. Is it correct, class? But still, some of you, from your answer, some of you still, I'm not sure whether you understand the concept of decision or not, because clearly over here, if you see from the question, the system, not the user, the system have to make some decision over here. Actually, there are two sets of decision, okay, to be made by the system. Okay, the first one is the system have to decide. Okay, the system has to decide what is the rate. What is the rate for a specific type of vehicle, kan? So let's say that is the one that using the system type 1 for type of vehicle, right? So the rate is going to be how much? One ringgit 50 cent, right? So if user entered 2 for the type of vehicle, so the rate is going to be this rate. So that one is decision, right? If, kan, if vehicle equal to 1, rate is 1 ringgit 50 cent. Else if vehicle equal to 2, so rate is going to be 2 ringgit and 20 cents, kan, and so on. So clearly there is a decision to be made over there, right? And the second set of decision is what, class? To determine what? So this is the first set of decision. Yeah, the second set of decision is based on this, based on this figure. So the question clearly mentioned that, okay, you can only enter the toll from where? From JB, right? So you can enter from JB, but exit toll can be either Muar, Melaka, and KL based on the number, right? So let's say if user entered exit toll is 2, so it is equal to Muar, right? So this one is important to determine the number of kilometer. The number of kilometer, kan? So why do we need the number of kilometer? To calculate the fees, kan? So the fees required number of kilometer and also type of vehicle rate. So when you got these two value, then you can do the calculation, kan? Then you can do the calculation to get this value. So it should have decision, kan? So if those who do only looping and without a decision, then your answer is going to be wrong, right? So make sure you really understand the question, kan? It is very easy, class. If you can see there's a question over there, kan? If, if you read from the figure, oh, if vehicle 1, then what? Else if, so if you convert it into a design, algorithm, a flowchart, so there should be a decision. Okay, so let's look at some of the answer. Okay, for example, from C13 kan. Okay, Wong Jun Yi. Wong Jun Yi. Are you here? Wong Jun Yi. Ada tak? Wong Jun Yi? Are you with us? Tak ada. Okay, so this is from Wong Jun Yi. Alright. So let's look at on the decision first. So decision, alright. So this is the first set of decision. Okay, to cover the tool kan. This one over here to cover the tool. First, if exit tool equal to 2, then distance is 50 kan. Okay. Location, wow. Okay. Else, if exit tool equal to 3, if yes, then Melaka, distance active. So this is the important thing over here, the distance value kan, because we want to do it, to use this for the calculation of the fees. So else meaning that this is for toll exit toll number berapa tadi? The last one So this is the value, okay, for distance. Okay. So your friend choose to have a very complex very complex design and however it is still correct. Okay. Why I'm saying that this is a complex design because if you see from here kan, let's say if the exit tool is moi. So over here you need to have the second set of decision, which is to determine the vehicle type. Okay, so for one is car kan, two is what, bus, and then what, three is for what, lorry Okay, so this is to determine the rate for each of the vehicle. For car, the rate is RM1.50. Okay, this one RM2 and this one RM3. So if you notice, this one is similar with this, right? Is it class? Same thing, right?
Yes.
And also the same things like this one. Very same. Okay, 100% same, right? So this is a compact design whereby you can combine actually all this into only one. Okay, choose only one. So the rest, okay, after getting the distance, it will enter here. Similarly, over here, remove this. Okay, remove the second set. And after getting the distance, you can go over here. Okay, and then it's going to be much more simpler. Boleh kelas? Okay, boleh Okay, and then print everything, do the calculation. Okay, correct. So this is to determine the counter kan. So in this case, your friend using exit variable for the counter. Meaning that exit will determine whether user want to do the looping or exit the looping kan. So if user enter, if user enter 0, then it will exit. Okay. So bear in mind, for Raptor for Raptor it is opposite with the official looping structure For official looping structure, it should be yes over here. Okay, if yes, then it will enter. However, for Raptor dia terbalik. Okay, it is opposite. If yes, it will go outside. So you need to redesign your flowchart if you want to test okay your flowchart with Raptor. So you have to modify this one, and yes. So it's supposed to be yes over here, and however you cannot change this in Raptor, and so by default yes outside of the loop, no enter the loop, and so you have to play around with the decision. Alright, because okay, so if you use a formal flowchart, so while over here exit equal to what? If you're using node Raptor, exit equal to
One.
is it equal to 1 lah. Okay, so we want equal to 1, it will enter kan. Betul tak the question? The question as exit, oh sorry, 0 for yes. Betul lah. Okay, 0 for yes, 1 for no, meaning that if user entered 1, okay, the loop is going to repeat again. Okay, the system will repeat the looping process again. So yes, you need to change this a little bit. Okay, don't follow 100% from Raptor. Okay, for formal flowchart, dia terbalik ini. So yes, supposed to be bawah ni lah for formal flowchart. You understand, class? Boleh
Boleh.
Yes.
Alright, so in this case, exit control the looping kan. So if user enter down here, if user enter exit 0, so dia akan keluar lah. Okay, it will terminate the looping. If user enter other than 0, so it will repeat again. Okay, repeat again the same process. So this is the correct answer. Okay. Okay, correct. Okay, next let's look at few more answer. Okay, one Muhammad Iqbal. Okay, one Muhammad Iqbal ada? Ada sini?
Ada.
Okay, what is this? Okay, salah. So this is wrong, Wrong, Iqbal. First of all, the types of variable kan. So car equal to 1, bus equal to 2, lorry equal to 3. No, this is wrong kan. So the choice of variable normally we choose a general. Okay, car, that one is specific. Okay, general, vehicle kan. So vehicle equal to 1 meaning that it is a car kan. So make sure you have a general point of view. Okay, if you do like this, if you go to specific, most of the time your answer is wrong. Okay, car equal to 1 ni salah. Itu return The rest of you, can you see this class? Yang ni boleh nampak?
Boleh.
Kan, car, bus kan? No, wrong kan? So this is to use for what kan? No use. I don't think you are going to use this value kan? 1, 2, 3 tak ada kan? No use. So no use, why you need to put it over here? No use kan? So enter type of vehicle. Okay, so this is correct. Okay, so enter 1, 2, 3 kan? Will determine the fair kan? So user enter 1, true, yes, correct. Go over here. If user enter 2, yes, correct. Go over here. False, go over here. Okay, correct. Then you have this. So this is wrong. Again, this is wrong. So enter location. Okay, again, the correct using of symbol also very important. So there's still some of you using during your midterm test, using inappropriate uh, types of symbol kan. For example, this one so this is not for input kan. For input and output process, okay, the symbol is like this. Okay, enter kan. Enter or print kan, display. Okay, input and output, this is the symbol. So if you're using this, then you will surely got it wrong for this, and you will not getting any marks over here. Although the name of the process is correct, however, the symbol is wrong, still wrong. Okay, so determine the location. Okay, correct. So this is correct. And then calculate the total fare. And then calculate fare multiply by distance. Okay, correct. Okay, so this is for the looping. Okay, to calculate total fare kan. Okay, no print Print. Okay, okay, let's look at this one. So your friend using do what kan. So decision is at the bottom of the loop body. So counter equal to 0, meaning that user to enter 0 or 1 over here. So if 0, it will repeat again. Betul kah? 0, it will repeat again. Okay, correct. Okay, 0 for yes. Salah lah kan. It's supposed to be 1 kan. 1 if don't want to exit. 0 if you want to exit kan. So wrong It's supposed to be 1 kan. Don't want to exit tadi kan. Is it correct class? 1 exit or not?
No.
No kan. So counter should be equal to 1. So if true, then no exit. Repeat again. Alright, repeat again. Repeat point over here. Okay. Okay, this one delete. Okay, however, if you look at from the question kan. So this is output kan. Okay, this is the output. Okay, output is repeated. Okay, not only we repeat the calculation, but output also repeated as long as user choose not to exit the loop. Meaning that your output should be inside ke outside of the loop body?
Inside.
Inside.
Inside kan. So you have to make sure you can differentiate kan which output should be inside of the loop, which output should be outside of the loop kan. So in this case, type of vehicle is output kan. Output inside, so location inside, distance inside, fare charge inside. What's the output after exiting the looping? Output outside of the loop. Which one?
Total fare charge.
Yeah, this one right. So after exit, okay, so this is exit equal to yes. So there's also an output over there. So total fare charge, the one that we accumulate, okay, the one that we use to accumulate the fare charge for each of the loop, right? So this is one time print only. So one time print meaning that it is outside of the loop. So this should be outside. Okay, but for our friend over here, all the outputs is outside. So wrong lah. So it should be 1, 2, 3. Okay, inside. Fair sum is outside. Kan? Fair sum is used to accumulate. So this should be outside. Okay, calculation inside. Okay, accumulation. Accumulation should be inside. Okay, counting and accumulating should be inside of the looping. Okay, the calculation itself. Okay, however, for the output, okay, for the output that user need to display and output kan, it can be either inside or outside of the loop. Okay, based on the given problem. So the question asks only printing one. Okay, one value for the accumulate result. So one meaning that it is should be outside. So this is correct. However, the three, the first three is wrong. This supposed to be inside. Sini lah dalam ni kan. Before entering the counter, print dulu. Okay, print everything. Okay, boleh? Okay, so Muhammad Hafiz, hopefully we can see other types of answer. So Muhammad Hafiz, uh, So this one, in terms of structure, I'm not going to run this. Okay. So generally this is wrong, because there are only two types of looping. Three types, kan? So the first one is while. Okay, the second one is do while. The third one is automatic. Okay, for this, so what should we put this? Is it while or do while? While the decision is on top of the loop body. Do while the decision is on the bottom of the loop body. So in this case, what? This is still repeating process, kan? And then we have the rest over here repeating process. So this is wrong. Okay. So if you already choose while, kan, so make sure that there is no other repeating process on the top of while decision. So this is the while decision. So you cannot put this here. You must put it inside. Inside. Okay, put it anywhere as long as not here. So cut. So maybe put it before. Is it kan? Okay, I remove this to here. So now it is become correct. Okay, while while. Okay, do while you cut everything. For example, if this is a do while, you cut everything. Okay, within the loop body, and this is within the loop body, and so you move it over here. So it become do while, kan? Do while, kan? Do the process first, and then check the repeating decision. Okay, the counter, whether correct or not. Boleh kelas? Okay, so this is correct, I guess. So this is also correct. Okay, do the calculation, print everything. Okay, if wrong, print accumulate. Okay, correct. So this is also correct answer. Okay, good. Okay, let's look at one more. One Hamzah. Okay, same thing. Is it the same answer? Copy paste lah. Okay, same mistake, Tuan Nur Khairina. Okay, where's the decision? Where's the decision? Counter also wrong. So if you put it like this, meaning that you didn't give user the choice to determine whether they want to proceed with the system, they want to proceed with the looping or exit the looping. So you have fixed the looping into how much? This one. How many looping? 1, 2, 3, 4. 4 loop. No, kan? This is wrong. And then there's no decision, kan? So where's the decision? So looping wrong, decision also wrong. Okay, so don't do like this. Siti Hawa. Counter yes, yes. Counter equal to yes. Okay, make sure for decision double, double. Decision should be equal. Okay, no decision. Wrong. Okay, no decision. So this is wrong. This is too specific, should be vehicle, vehicle, and then decide, Okay, wrong. Okay, so we see some of the answer wrong and correct answer. Any question before we move to new topic? Ada tak?
No say.
Dah record kan tadi? Okay. Okay, so today we're going to discuss new topic which is introduction to programming structure. This is most important part of this subject class because you really need to understand this. Okay, you need to, because it is quite, sometimes when you just reading from the notes, you will find yourself lost, okay? Lost in the terms, and there are many terms over here that you need to know. You need to know the terms and you need to know how to do it. Okay. So introduction to programming structure mainly cover on the modules part of the system. Okay, before this, during the you're already going through the question for mini project kan? Dah kan? Mini project punya question. So
Yes.
you need to develop a design for modules and non-modules kan? So the non-modules part, okay, we already finished cover kan? So non-module, it can be sequential logic structure, decision, and also looping. So it can be either one or combination. Okay, non-module. So right now, okay, in this topic, we are going to cover modules. Modules. So basically, we can have the same program. Okay, let's say we have program A and program B. Okay, the same program. Okay, for example, the same program to calculate toll toll fee tadi tu kan? Toll fee. A to calculate toll fee, B also to calculate toll fee. Okay? So the input is similar, the output also similar. When user run both A and B, they will get the same interface, same input and same output. Okay. However, we can develop A and B by using a different structure. Okay, A, the one that we already developed, is using non-module structure. Okay, B, the same program, but we develop it using module structure. Okay, so not necessary that all programs should be module or all programs should be non-module, kan? It can be any. Alright. So let's say you are required to develop a module structure program. So what should you know? Okay, so first you should be able to differentiate between modules and function. This is the easiest one. So what is module? Each module should have its own specific function. That's all. Okay. So different module we have different function. Okay, able to differentiate between cohesion and coupling. Okay, so this is a very popular terms in this topic. So what is cohesion? What is coupling? All right, and then uh, local and global variable. Okay, parameters. So local, global, parameter. This is very important if you want to apply the coupling process. So we have cohesion and coupling. So for coupling, the important term is local, global, and parameter. Okay. So in the end, what does this the outcome of this chapter? Of course, to produce a design that involving a modules. Okay, that involving a series or a set of modules. Okay, that's our main objective. Alright, I'm not going to really read from these slides. Okay, but just for introduction. Okay, so car. So what is this related to this topic kan? So it is easy class. Let's say if uh, a company like Proton kan want to develop a new car kan, new model, new Proton model kan. So what did they do is they are not building one model. Okay, they are not building it by using one team kan. So not one team develop the whole model, right? No, right? So okay, one model, for example, engines, okay, will be developed by team A. Okay, wheels will be developed by team B, and then chassis and the mainframe of the car will be developed by team C. Okay, so and then after everything is finished, then they combine all things together, and all things, okay, all these A B C team they should have the same same what say so that when the team that building the engines, once it is finished, it can be put inside of the car chassis, okay, successfully. Otherwise it won't be complete car kan. If you build it if you design engines for a van, you cannot put it inside of car kan. Or maybe if you design the engine for Savvy kan, Proton car kan, and then you want to put it inside of apa, X50 kan, the new one kan. So it won't be matched kan, although from the same company but different types of engines. Do you get it, class? Do you get what I mean? Meaning that to develop a program, similarly, if you have one program, okay, usually the program development process not going to be developed by a single team. Okay, they will be more than one team. Okay, and then each team will have their own task. Okay, for example, team A will develop module A, module kan. Team B will develop module B. Team C will develop module C. So once uh, each of the team already finished, completed their task, and then they will combine module B, module C to become one single program. Faham tak? The concept of module.
Yes.
Kira Okay.
Yes.
So, alright. So basically, how to write program module types of program is by you already going through this process class actually. Okay, so we already developed the PAC, and then the most important part in module is the IPO. Do you still remember IPO? What is IPO, class? So IPO is used to break the problem into modules. If you notice, okay, inside of our IPO, so this is from chapter 3 notes kan. Sequence logic structure. There's one. Where's the IPO? Okay, IPO. Do you see there's a module over there? So why do we differentiate? For example, this one module read, this one module calculate, this one module print. So this is a simple one kan. Let's say if we have a longer program, and then we have to really identify, okay, line 1 should be put in what module. Okay, so this is the first step. This is the first step. Break problem into modules. So we have a set of solution kind of instruction that is inside of the IPO, and then we determine. So each process maybe belongs to what module kan. And then after we finish, okay, we take out the same, we take out the same process, okay, the same process in the same modules. This is later on, exercise. Okay, let's look at this one. Okay, so we have IPO to calculate average of three numbers, and so there's no looping, no decision over here. This is sequence logic structure. Okay, later on, okay, we'll discuss if the problem involving decision and looping. Okay, so we have two process that we already categorized. These three belongs to read module. So we take these three and we put it inside of read module, and then we give this task to team A, okay, to complete the module. Okay, and then we have second module which have a calculation. Okay, we take this process, we give this to team B, which will be assigned to complete the calculate module. Okay, calculate module. Do you understand this, class? And then we have uh, the third module, which is print, and so we take this and we give this to team C. Okay, so team C will do the print module. And finally, we have average control. So this is the main program that will bind the rest of the module together. So there should be a main program that control the rest of the module. So in this case, what is the main program that is controlling the rest of the module? The module is average control. So this is the main module. So we take this and we give to team D, okay, to complete everything. So now we have 4 teams that have to develop 4 different types of module. Okay, do you understand the first process? Boleh?
Boleh.
So we have 4 different modules. So currently we have 4 different modules. Okay, so let's develop a program that is using module structure. Okay. Alright, so we have this IPO. So this is without module, kan? Non-module. So this is flowchart without module. This is the algorithm without module. Is it correct, class? Is it
Yes.
correct algorithm? Okay, let's say given to you this and non-module. So your job is going to be easier. Okay, if not, then you have to develop the design based on the IPO. Okay, so identify the same read. Okay, identify the same process. Okay, so we are going to develop a read module. Okay, read module, the name of the module should be put inside of start. So when we are using module, there's no start anymore. Okay, so it will start with the name of the module. Okay, if read lah, calculate. Okay, print, average control. Okay, so start with read. Okay, and then take all the same process within the same module. 1, 2, 3. Is it correct? This one kan? 1, 2, 3. Ah, copy. Okay. And then after completed, we put not end but exit. End is the end of the program. Okay. But if you have more than one module, it's not the end of the program yet. It's just exiting from this program, this module. Okay. Okay. It's just exiting from this module. Then finish. Okay. Team A already finished for module read. So you will get mark from here. 1 mark for one module, finish, completed. And then moving to the second module, which is calculate. So do the same process. Again, this is easy since it is not involving any decision and looping. So make sure you really understand the easiest part. Next, you are going to move on the decision and looping. Then you get headache on that. Okay, so what's the process for calculate? Calculate only have calculation over here. So we take the calculation part. Okay, put it inside of calculate module. Okay, and then we end the module with what?
Exit.
Exit.
Yes. Okay, exit. Okay, so moving to the next is print. Okay, print module. Okay, so same thing. So we have print module. Then what should print module do? It have only one process, print average. So one process kan, ni kan processnya. Okay. So team C finish. Next is team D. Okay, so develop the main module, which is the control, average control kan. Okay, same thing. So we need to have tadi average. Ini okay, make sure you don't mistake it with the rest of the module. So what should this module do? Let me put here so that you don't get confused. So this is non-module. So this is a non-module. This is non-module. So if the question asks you to develop non-module, this is your answer. If the question asks you to develop a module, you don't have to write this one. Okay, this one shouldn't be here. So delete this. The answer is 1, 2, 3, this one only. Okay. So what should be inside of average control? So as I mentioned, yeah, as I mentioned, is average control used to bind the rest of the modules together. Okay, meaning that it will call, okay, the rest of the module based on their flow. flow kan. So let's look at the original flow. The original flow, what modules should come first?
Read.
Read.
Read. So over here we call module read first. Okay. So we call module read. How to call module read? By using a module symbol. Module symbol, if you are using words, this is the symbol. Okay. Predefined process kan. This is symbol for module. Then what should you put inside? You just put the name of the module. Read. So read kan, sama kan? Kalau besar-besar lah. It is capital, then you should write it as a capital. Right? Okay. Okay, so next after finish with the module flow kan. So dia baca dia, how you read this is like this kan. So average control read. Okay, call module read. So it will call module read over here. Okay, and then the system will do everything inside of module read. Enter number 1, enter number 2, enter number 3. And then it will exit module read and then goes back into the module that is calling it. So the module that is calling read is this one kan. So it will goes back over here and then it will go to the next. Okay, it will go to the next module, which is module what?
Calculate.
Calculate.
Module calculate. Module calculate. So it will call module calculate. Call module calculate. Okay, it will do the process inside of module calculate. And then after finish everything, it will exit module calculate and return back to control. And next, it will call what module?
Print.
Print.
Okay, follow the flow inside of IPO kan. So this is why this very important kan. So this is why. Okay. So next is print. Okay, same process. We call module print. So we go here, call module print, and then we do the process within module print. Exit module print goes back to control, and finally it will
And
finally we end the process. Not exit anymore. Okay, exit for modules, but for control is end. Okay, control is the main module. So it should be ended with end. The rest exit. Understand, guys? Any
yes.
question?
Yes.
No.
No.
No questions, sir.
No question. Okay. So what should you put inside of your answer, kan? So which one? All this lah. Okay. 1, 2, 3, 4. 4 independent flowchart. It doesn't connect kan. There's no arrow kan. From here to here, no kan. It is independent. So the independent concept of a system design is where we is what we call as a cohesion. Over here, cohesion. Okay, cohesion mana tadi kan? Cohesion is independent. So each module is independent. So from the design we can see that there's no arrow kan? There's no arrow kan? So it is independent. Okay. So how to connect all these independent module? Okay, by calling it inside of the main module. So how do we link all these independent modules together is what we call as coupling. Okay, so we have different types of module. We want all these modules to work together. So what are the concepts that we must apply? We must apply coupling concept. Okay, so there are a few techniques how we can couple all these modules together kan. That one is covered inside of this global and parameter. Okay, so ready? Okay, so this one already finished So this is the complete design. So we finish for flowchart. Flowchart is very simple. Okay, very simple. This is flowchart. Okay, however, if you are requested to develop a module system, okay, using algorithm, so it's going to be a little bit complicated because you need to be details. Okay, so the details of uh, the value. Okay, since we have a different module, so each module is producing its own value, right? So you need to share this value with the rest of the module kan. Since it is independent, so you need to share all this value to the rest of the module. For example, in order to calculate average in module calculate, so you need a value of number 1, number 2 and number 3. Is it correct? So where can you get this value? Where can you get this value?
Read.
This value is generated by module read. So you somehow need to have one mechanism, okay, to transfer the value of number 1, number 2 and number 3 from module read to module calculate. So that module calculate can use this value to calculate average. So you need to show this movement, the value, the data movement inside of algorithm. So that's why we need algorithm. Okay, to see the overview and the general structure of the program. Okay, we can use flowchart. However, to see the details kan, the details of the data movement, we need to use algorithm. Okay, for modules. Yeah. Okay, so algorithm. Okay, to see the data movement. Okay, same things. So first we build the general design first. The general design is the same as this one. Okay, first we must have main module, which is average control. Okay, right. So this is null module. So this is null module. So we are going to develop new algorithm. So again, it is same things. What should it do? It will what? What is this class? Meaning what?
Call read module.
Yeah, it will call read module. So do the same over here. Okay. How to write calling is just putting process and process module read. And then we have this bracket. So this is important. We are going to fill this bracket with something over here. So after finishing with the read module, then we proceed with calling process calling module calculate. Okay. Next we call module read. Finally, we do what over here?
And
And okay, right. Okay, finish. So next, moving on to module read. Okay, we do the general structure first kan. So similarly, we have the same process kan. Enter number 1, number 2, number 3. So just put the process that is related to module read, okay, within the body. Then what? And or is it?
Is it?
is it
Exit. Okay, finish module read. So next we have module calculate. Next we have module print. Okay, finish. So general structure, you already got some marks over here. Okay, but the most important thing is the movement of the data. Okay, first we look at module read. So module read is generating number 1, number 2, number 3 kan. So we want to transfer number 1, number 2, number 3 into module calculate. So how to transfer? So one of the way is by transferring this data into control first, and then control will pass the value of number 1, number 2, number 3 to calculate. Okay, since this is since control is the one that bind all the other modules together kan. So we must do that lah. So how to transfer number 1, number 2, number 3 into control is by using parameter. So what is parameter? Parameter is a variable that we use to transfer value to one module to another. Understand? What is parameter? Parameter is actually a variable. Okay. What kind of variable? A variable that we use to transfer a value from one module to another module. So in this case, we want to transfer number 1, number 2, number 3 from read to what module?
Calculate.
Wrong. We want to transfer to module
average control?
average control. Okay. So once average control got this value, and then average control will transfer this value to module
Calculate.
calculate. Okay. So that's the flow. So the flow is first we must transfer number 1, number 2, number 3 by using parameter. So how can we define a parameter? Okay, you copy this variable, you put it inside of the bracket. Now it become parameter. So a variable can be a parameter. So why we need parameter? If you want to transfer a value from one module to another. Okay, so rest list all the variable that we want their value. So let's say we want 3 variable values. So list 3 over here. Okay. If you want only number 1 and number 2, number 3 no need to be transferred, then put number 1, number 2 only. Understand? Within the bracket. Understand?
Yes.
Okay, so transfer this value into average control. So average control must receive. So how it receive? So you must also receive by listing down the parameter. Okay, understand? So the question is number 1, number 2, number 3 in module read similar with variable number 1, number 2, number 3 in average control? Is it the same variable? Not the value. The value is going to be similar, kan? Since we pass from read to average control. But in terms of a variable, although the name is similar, is it the same variable? The answer is no. Okay, you must remember the cohesion. Cohesion is independent. Each module is independent with each other, meaning that the variable over here, although the name is similar, but it is different. Number 1 here is totally different from number 1 here. Okay, since it is different, can you put other variable over here? The answer is yes. Kan? For example, over here, I use A, B. Example kan. You cannot use this kind of name kan. A, B, C. Should be meaningful kan. So, A, B, C. This one, number 1, number 2, number 3. Can we do this? Do like this? The answer is yes. Name is not important. The important is the value that we transfer. For example, number 1 entered by user here is 10. So 10 will be passed by number 1 to A. So what is the value of A?
10.
10 lah. Okay. So name is not important in modules. Okay. The important part is the value that we transfer. Understand, class?
Yes, sir.
Any question so far? Any question?
No, sir.
No kan? Okay. So to avoid confuse kan, usually I use the same parameter name lah. Parameter in between the bracket is parameter. But you need to understand these are different. Okay, these are different from here. You can use the same name. Okay, you can use the same name. However, you must understand it is a different variable. Okay, different to avoid confuse, we use the same so that we know that the value is similar. But you can use different name. You can. Okay. Okay. So next, we got all this value. Next, we want to transfer this value into module calculate. How we do that, class? Logically, macam mana? How we transfer this into module calculate? How? Any idea?
Pakai parameter.
Yes, correct. So we use the same technique, which is passing the parameter. Okay, passing the value using parameter. So how to do parameter passing? Okay, over here, put it inside of calculate. Okay, so pass number 1, number 2 and number 3. Okay, from average control to calculate. So calculate must receive. So how calculate receive? How calculate receive number 1, number 2, number 3 from control?
Tulis balik variable.
Yeah, by receiving through parameter. Okay, parameter. Okay, parameter we put it inside of bracket. So the same, you can use the same name or again you can use different name kan. For example, this one norm 1, norm 2, norm 3. Can we do this? Yes, because it is cohesion. It is independent. Kan? Name is not important. The important thing is the value that we pass. Faham? So right now, since we are passing 10 over here, so what is the value of norm 1?
10.
10. So how we calculate average? How we calculate average? Since we are using norm over here, this one should also be changed. Okay. So we use norm kan. So you cannot use number kan. So number, you will get error over here. What is the value of number kan? We don't have this value. The one that we have is norm because we are inside module calculate right now, not module average or module read. Okay. So this one need to follow here. If you use number 1, then this should be number 1. Understand? Understand or not?
Yes, sir.
Okay. In this example, I'm using different names so that you know you can do this, kan? Not necessary to be the same, kan? The same over here number, this one number, no, kan? It is cohesion, kan? It is independent. Value the same. Name is can be different. Okay, so now we already got the value of average. Next step is what? We need to print average, right? But the print process is in a different module. So what should we do?
Parameter.
What parameter?
Pass average.
Pass average to what module?
Read. Print atas. Print.
How can we transfer? How can we pass average to print? Can we directly pass? Boleh? Can we directly pass?
Oh, hantar average control.
So we must pass first the value to average control. And then from average control, we pass the value to, ini bukan print ni, apa tadi? To print, kan? So how to do that? By using parameter. Macam mana? Pass lah. Okay, pass apa? Average. So pass average. This one over here should also receive average. Okay, understand? So next what? After we get the value of average from module calculate, how can we pass it to module print?
Letak pass average punya parameter dekat print.
Yeah, correct. So inside of average control module, we put parameter average. Okay. When we call module print. Okay, we call module print. This is call module, and we call and we pass. Okay. We call this module along with the value of average. So when the system okay receive when the system calling the print module, it will also sending the value of average. So you can use the same name average, or you can use different name also can. So let's say if we use same name average, okay, so we print average exit. Do we need to pass any value over here? Over here we pass the value of average kan. From module calculate we pass average to module control. And then module control pass average to module print. Okay, module print will get the value of average. It will print average, exit. The module print need to pass any value from here to control.
No.
No value need to be passed kan. Since it is not generating any value kan. It just print. It doesn't generate any value. Okay, generate. This is also important term kan. For next step, okay. So it doesn't generate any value, so it doesn't have to pass anything. But if it is needed to pass anything, so you just put over here lah. What's the variable? What is the value you need to pass? Okay, within what variable? So put it over here. So the variable will become a parameter. Okay, so exit module print, exit, it will goes back to control, okay, over here, and then it will end the whole process, okay, the whole system. Okay, so far, any question, class? Any question? No?
No, yeah.
Boleh senang kan? Senang ni kan? It's quite easy if we start with sample first kan? That's why I'm not going to read the whole notes, lecture notes first kan? We go to example first. Later on, I need you to read again the lecture notes because very important terms is still you need to know the terms. Okay, are we finished over here? No, not yet kan? No, we are not finished yet. Okay, there are still okay, let's put over here. So this is non-module, this is module kan? Okay, so we are not yet finished because if you put it over here, the parameter is incomplete. Why is it incomplete? Because of the generate term kan? Okay, so look at all the modules and find out each of the modules generating what value. Okay, for example, module read is generating number 1, number 2, number 3 kan? Correct. So you put asterisk. Asterisk This is what we call? What we call this one? Is it asterisk?
Yes, asterisk.
Asterisk Okay, you put asterisk. Since this value is generated, since this module generated these three value, you must put asterisk over here. Why we put asterisk? Let's say if we didn't put asterisk okay. So when people read, your algorithm, they will read it like this. Okay. Everything will start with average control kan. So they will read process read passing number one, number two, number three. Is it correct? Passing number one, number two, number three to module read. From control, we are passing this value to read. Is it correct? It's vice versa, right? Read is the one passing number one, number two, number three to control. Is it correct? Huh?
Yes.
Okay, so you need to put asterisk if number one, number two, and number three is generated by read. So put asterisk. Yeah. There's an explanation about this later on, okay? But for now, the easiest way to design is remember this. If that particular module generating this value, so you need to put asterisk inside of the parameter. So this is the parameter. We put asterisk since this generate number one, number two, number three. So how it generate? By asking the user to enter the value kan. So it generate the value. Okay. User lah enter kan. But this module where this value comes from. Understand? Boleh? So have asterisk over here. Inside of control also must have asterisk. Okay. So moving to process calculate. Process calculate, which parameter should we put asterisk? Is it everything?
Average.
Average only.
So look at the variable that is the value generated within calculate. So calculate only generate average. Norm 1, norm 2, norm 3, the value is received from average. Control kan? From control. So control passing this value. It is not generated within calculate body kan? Tak ada kan? So calculate only generate average by executing this equation. So put asterisk in front of average only. Okay, so similarly, we put asterisk over here. Okay, next, moving on to process print. Okay, process print. Do we need to put asterisk over here?
No.
No, right? Since it is not generating average. It is using the value of average that is that got from control kan. So control passing the value of average over here, then it receive and then it will print. Okay, without having to generate new value kan. If there's any new value over here, then you need to put asterisk. So how do we really read this algorithm? Okay, so over here, when we call module read, we are still passing. Not passing a numbering value, but we are passing the address of number one, address of number two, and address of number three. That is why we put asterisk. Asterisk in front of variable, meaning that we are not passing the value. We are passing the address of the variable. So why do this important? Okay. So over here, when we are passing the address of this variable, so inside of module read, it will receive this address. Okay. Once it receives this address, okay, over here modification is done in number one. So in number one what? In number one address. So let's say user enter 10 over here, it will be saved inside of address of number one over here. So what is the address of number one over here? It is the same address as number one over here. So automatically, it will also save this value over here directly to here, since it is the same address that we are referring to. Okay, so this is different from here. Over here, no asterisk, so we are passing a real value, okay, not address. So when we are passing a real value over here, okay, this one we receive the real value. So if anything happen, anything changes over here, it will not affect the address, okay, the original value inside of this address. Do you understand? Asterisk and no asterisk. Boleh faham tak? Huh? Do you understand, guys?
Understand.
Yes, sir. Why we need asterisk and why we didn't require asterisk. So at first I show you how to do it. Okay, how to differentiate between module that need to put asterisk and not. And then second, I explain the logic, okay, behind it. Okay, so what should you know? You should know the first one. The first one you need to know how to differentiate parameter with asterisk and without asterisk. That's the important part for your marks. The second one is the fundamental, and the fundamental why we do that. That's also very important. But if you don't understand also, okay, but you need to know how to do it. Yeah. Okay, any question?
No, sir.
No question? Okay, so no question. I will give you one question. So this is taken from decision logic structure notes. Okay. Okay, have a look at this. There's an IPO over there. Okay, if you want to, if you don't want to reopen the notes, okay, just take a picture of this. Okay, what I need you to do is you need to come out with flowchart and algorithm. Okay, flowchart and algorithm for a module structure. Okay, module for flowchart and module for algorithm. Boleh? Understand what to do? This one, okay. This one from decision logic structure notes. Okay, there's a IPO over there already predefined for you. So your task is to develop all the modules related by using flowchart and algorithm. Okay, with modules. Okay, before I forget, okay, actually we are not done with this yet. So once you finish everything, you must combine all together because algorithm. Okay, algorithm, to check the algorithm easily later on, if you are requested to develop the dash checking, so you need to have the same line continuous number kan. So this one just continue ya. Okay, once you finish everything, you just continue the numbering so that once you want to test it, it is easier for you to refer kan. Which line kan. Okay kan. For example, over here kan. So after line number 2, so what should you do kan? So you will skip the rest of the line. You will go to line 6 kan. Line 6 and then enter number line 7, line 8, line 9, and then exit. You will go back to line 3. So from line 3 you will go to line 11. So line 11 do average and then exit and so on. So it should have one continuous number lah. Okay, so that's all. If no question, finish the task and submit. Submit. I think we are not going to have live class tomorrow. So make it your macam mana? So you may submit this before the end of lab tomorrow, boleh But for tomorrow I will give you different question, boleh? Boleh. So submit before the end of lab session 10 AM tomorrow. Okay, so that's all. Thank you. Assalamualaikum.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Okay, thank you, Doctor.
Thank you, Doctor.
Assalamualaikum.
Assalamualaikum.
Thank you, Doctor.